Hello viewers, in today's lecture we are going to solve some problems related to application of integrals. So the first problem is find the area enclosed between the parabola y square equal to 4ax and y equal to mx. So our first aim is to identify the curves. So this is a parabola and the vertex is at origin, and this is the equation of a line which passes through the origin. So let us first draw a rough sketch of these curves and see this is the parabola and the line can be drawn like this which passes through the origin, right? So this is the line y is equal to mx, and this is the parabola y square equal to 4ax. Now our aim is to find this area, right? We have to find the area that is enclosed between this parabola and the line. So for finding out this area, what we will do, we will make use of the concept of integration, and from here this point, say this is point P, this point P is the intersection of point P is the intersection of parabola and line, right? Parabola and line. And from here we draw a perpendicular, say this is point M, and in order to find the point of intersection of these two curves, we will solve these two curves. So we have y square equal to 4ax and y is equal to mx. If we substitute the value of y here, we get m square x square, and this is 4ax, and we have m square x square minus 4ax equal to 0. Taking x common, we have m square x minus 4a equal to 0. So x is 0, and m square x minus 4a is equal to 0. So x is 4a divided by m square, right? So the point of intersection of these two curves is if we take x equal to 0 here or here, we get y is equal to 0, and if we substitute x equal to 4a by m square here, we get the value of y as 4a divided by m, right? So the point of intersection are 0, 0 and 4a by m square, 4a by m, right? So the coordinates of the point P are these: 4a by m square, 4a by m, and the coordinates of this point O or the origin are 0, 0. So this point is your 4a by m square, 0, right? Now we have to find this shaded area. So this shaded area can be calculated by drawing two strips. So the first strip is from the parabola, it touches the parabola, and the second strip touches the line, right? Okay. Now see, we have to find this shaded area, and the first strip, it touches the parabola, and the second strip, see this is the second strip, and it touches the line. So the shaded area is from A to B. The general formula is from A to B, and we have y1 minus y2 dx, right? Where y1, this y1 comes from the equation of the parabola, and y2 comes from the equation of the line. So here it can be written as, because the value of a is 0, we are integrating from 0 to 4a, by m square, and here for y1 we have the parabola, and for y2 we have the line, right? So here yp comes from this equation of parabola. So we have 0 to 4a by m square, and yp is square root of 4ax minus yl comes from here, this is mx, right? And here we have dx. Now this is 2 root a, this is square root of 4 is 2, and 2 times square root of a, then we have square root of x minus mx, and here we have dx, and the integral from 0 to 4a by m square, right? Now if we calculate the integral of square root of x and x, we have here we have 2 times square root of a, this is 2 times square root of a, and this is x 3 by 2 divided by 3 by 2, and minus m, this is x square by 2, right? And this is from 0 to 4a by m square, because the square the integral of square root of x is x raised to 3 by 2 divided by 3 by 2, and the integral of x raised to 1 is x square by 2. Now we'll calculate it. First we substitute this value of x. So we have this is 2 square root a, this is 2 by 3, and for x we can write 4a by m square 3 by 2 minus m by 2, and for x square we have 4a by m square whole square, and then we will substitute 0. So here we have 0, here we have 0, so in all we have 0, right? Now this is 2 to the 4, 4 by 3 square root of a, and here we have a raised to 3 by 2, and then we have 4 raised to 3 by 2, and this is m cube, right? Because 2 and 2 get cancelled, so we have m cube minus this is m by 2, this is 16a square divided by m raised to 4. Now this is 4 by 3, this is a raised to half plus 3 by 2, so this is a square, and here we have 2 square, so square square cancel, we have 8 here divided by m cube minus this is 8a square by m cube, right? So this is 4 8s are 32a square divided by 3m cube, right? Minus 8a square divided by m cube. Now we take this is 32 by 3 minus 8, and we have a square by m cube, and this is 3 8s are 24 by 3 a square by m cube. So this is equal to 8a square by 3m cube. So this is the area enclosed between this parabola and the line. Clear? Now suppose if we have a parabola y square is equal to x and y is equal to x, here I am considering some special cases. This is a special case. If we have a parabola y square equal to x and y is equal to x is the equation of the line, then we will follow the same steps and we will find the area. So here if we compare this equation with this equation, then we have 4a is equal to 1 and a is equal to 1 by 4. And if we compare these two equations, we have the value of m as 1. So what is the area enclosed between these two curves? If we take y square equal to x and y is equal to x, then we can simply substitute it here. So we have 8 times, this is 1 by 4 square, and this is 3 times 1 is 1 cube. So this is 8 multiplied 1 by 16, and this is 3. So this is 8 2s are 16, and we have 1 over 6 square units. So the area enclosed between this parabola and this line can be calculated as 1 by 6. But here we have substituted directly the values of a and m in this result. But if we are asked to find the area enclosed between these two parabola and the line, then we will follow all these steps, right? Now viewers, let us take one more problem. So here we have to find the area of the smaller region bounded by the ellipse. The equation of the ellipse is given here, and the equation of the line is given here. Now if we compare this equation of ellipse with this equation, that is x square over a square plus y square over b square equal to 1, we see that a is 3 and b is 4, that is 2, right? So here we have 3 comma 0, here we have minus 3 comma 0, here we have 0 comma 2, and this is plus minus 3, and this is plus minus 2, and here we have 0 comma minus 2, right? So this is the rough sketch of the ellipse, and we have to find the area of the smaller region bounded by the ellipse and the line. So if we compare this line with x over a plus y over b is equal to 1, then we see that this line passes through these 2 points, right? That is 0 comma 2 and 3 comma 0. So the line can be drawn like this. This is the equation, rough sketch of the line. So this is the line x by 3 plus y by 2 equal to 1. And now we have to find the area of the smaller region, right? Now it means we have to find this area, this shaded area. Now for this what we will do, we will take 2 strips. One strip is like this and other strip is like this, right? So this is the larger strip, this is the smaller strip. This elementary strip touches the ellipse, and this strip touches the line. So what is the shaded area? So shaded area is given by a to b, integral from a to b, and then we have y1 minus y2 dx, right? So here the value of a is 0 because we are in the first quadrant. So the value of a is 0 here. So we go from 0 to minus 0 to 3, and y1 is the value of y which comes from the ellipse. So we have y ellipse minus y line, right? And then we have here dx. Okay, so we have 0 to 3, and the equation of the ellipse is given by this equation. So ye comes from this equation. So we have this is 2 by 3 square root of we have 2 by, that is 9 minus x square, minus, and the value of y which comes from yl comes from this equation of line, so this is y by 2 minus x by 3, so this is y, and 2 minus 2x by 3, this can be written as 6 minus 2x by 3. So here we write 6 minus 2x by 3, and now we have to calculate the value of this integral. Now I am taking this integral as I1 and this integral as I2. So we have here I1 minus I2. So we will separately calculate the value of I1 and I2. Now I1 is 0 to 3, 2 by 3 square root of 9 minus x square, taking 2 by 3 out of this integral, and then we have 0 to 3 square root of 3 square minus x square. Now to calculate this integral we will make use of this formula. So we have 2 by 3, and then we have x by 2 square root of 3 square minus x square plus a square. For a square we have 3 square, that is 9 by 2 sine inverse x by 3, right? And we have from 0 to 3, so we have 2 by 3. If we substitute 3 here, so 3 square and 3 square gets 0, so we have 0 plus 9 by 2 sine inverse, and here 3 by 3 gives 1, and if we substitute 0 here, this becomes 0, this becomes 0, so we have 0 plus 0, right? And this is equal to this is 2 by 3 times 9 by 2 sine inverse 1. Sine inverse 1 is pi by 2, and this is 2 and 2 get cancelled, so we have 3 3s are, and this is 3 pi by 2, right? This is 3 pi by 2. So viewers, the value of this integral I1 is here I am writing 3 pi by 2. Now our aim is to find the value of I2, and I2 is given by this integral. Now I2 is integral from 0 to 3. We have 6 minus 2x by 3 dx, and this is 1 by 3. Taking 3 out of the integral, we have 0 to 3 6 minus 2x dx, and this is 1 by 3. Here we have 6x. The integral of 6 is 6x minus 2x square by 2, and from 0 to 3. Now this is 1 by 3. 2 and 2 get cancelled, so we have 6 minus x square, 0 to 3. Taking the value of x3, x equal to 3, here we substitute, so we have 6 3s are 18 minus 3 square is 9, and then we have minus, here we have 0, here we have 0 square is 0, right? So 18 minus 9 is 9, 9 by 3, that is 6. 9 by 3, sorry, this is 9 by 3, that is equal to 3. Clear? Okay, so the value of I2 is 3, and therefore the area of shaded region, this region is 3 pi by 2 minus 3, or it can be written as 3 pi by 3 pi minus 6 by 2, or it can be written as 3 times pi by 2 minus 1 square units, right? So viewers, this is the value of the area of the smaller region bounded by this ellipse and the line. So in this lecture we have solved two problems, and these two problems are very important. And viewers, you must have seen that how we have drawn the rough sketch of the curves which are given to us, and how we have calculated the integrals, right?